Welcome to GRADS COMPEER. In this video, we will solve a numerical problem on resolving forces or finding the components of forces. Let us read the problem carefully. Compute the x and y components of force P shown in the figure below with respect to an axis parallel and perpendicular to horizontal plane and vertical plane. So we are going to resolve this force P with respect to a horizontal plane and inclined plane. In order to resolve this force P, we need to do three things. First is to indicate the direction of the axis. Second, to indicate the directions of the components. Third, to find the angle which the force makes with its x component. Then we can find the magnitudes of the components of force P. Now resolving with respect to horizontal plane. So with respect to horizontal plane means the x-axis should be drawn parallel to horizontal plane and y-axis should be drawn perpendicular to horizontal plane. Now second one, indicating the directions of components of force P. The x component should be drawn parallel to x-axis and y component should be drawn parallel to y-axis. So this is minus px and this is minus py. So the negative sign is because the directions of the components are indicated in the negative x and y direction. You can observe here that the px is drawn parallel to x-axis and py is drawn parallel to y-axis. Now someone may question why I cannot draw the px in this direction which is also parallel to x-axis and py in this direction which is also parallel to y-axis. But the thing is, it should conform to the parallelogram law. If we draw two lines parallel to px and py, then the resultant force should be passing through the diagonal. But the given force is in the reverse direction. So therefore, the directions of the components are wrong. Here, px and py are called components of this force P and P is called resultant of px and py. Now the third thing is to find the angle between the force and its x component, that is theta. So let me call this as theta p. So someone may say, sir, why can't we find this particular angle? Let us say this is alpha p. So we can do it, but the thing is that suppose if this angle is known theta p, then the x component will become cos component and y component will become sine component. But on the other hand, if I find this angle theta p, which is angle between the force and its y component, then this becomes cos component and this becomes sine component. Just to avoid confusion, for every problem we should stick to only one thing. Either we find the angle which the force makes with x component or y component. Throughout all the problems we should only stick to one thing. So I am preferring to find the angle which the force makes with its x component only for all the problems. So once you find the angle theta p, then finding the components is very simple. So px will be equal to p cos theta and py will be equal to p sin theta. Here the magnitudes will be negative. Next, we will see how to resolve the forces with respect to inclined plane. With respect to inclined plane means the x-axis should be drawn parallel to inclined plane and y component should be drawn perpendicular to inclined plane. Now the components of force P should be drawn parallel to this particular axis. The x component of P should be drawn parallel to x-axis and y component should be drawn parallel to y-axis. So this is px which is also negative and this is py which is also negative because both are directed in the negative x and y direction. So here you can observe again the px is drawn parallel to x-axis and py is drawn parallel to y-axis. Now we need to find the angle which the force makes with its x component. Let me call this as alpha p. So once we find this alpha p, then we can find the components, that is px will be equal to minus p cos alpha and py is equal to minus p sin alpha p. Here also this theta p. Okay, only three things. First is we need to indicate the axis, whether we are orienting the axis with respect to horizontal plane or inclined plane. That is first. Second thing is draw the components of the forces parallel to that particular axis. If it is horizontal plane, then we have to draw with respect to this particular axis. If it is with respect to inclined plane, then we have to draw with respect to this particular axis. Next, we need to find the angle which the force makes with its x component. Then we can find the components px, py. Px is p cos theta, py is p sin theta. Now let us resolve force P with respect to xy axis which is drawn parallel and perpendicular to horizontal plane. So already these things are given here. We need to find this angle theta p. So you see now, suppose I draw two lines which are parallel and one inclined line which is intersecting those two parallel lines. Then you can observe that these two angles will be alternating angles which will be equal, isn't it? Similarly, if I draw one line parallel to this px and another line parallel to this horizontal 3, the slope of this force is given here 3 horizontal 2 vertical. So horizontal to this I have drawn another parallel line. Now this line of action of this force is the inclined line which is intersecting these two parallel lines. So now you can observe here that this angle will be equal to this angle. So if this angle is theta p, then this angle will also be equal to theta p. So therefore this is theta p. So how to find that theta p? Very simple. Take tan theta. Tan theta p equal to opposite side by adjacent side. So in this particular triangle, this is opposite side, this is the adjacent side. So tan theta is equal to opposite side by adjacent side. So 2 divided by 3. So theta p is equal to tan inverse 2 by 3, which we get it as 33.69 degrees. So once we found this angle, then we can find the magnitudes of px and py. So px is equal to minus p cos theta. Do not forget to put this minus here, which is equal to minus the force P is given as 361 Newton cos 33.69. So the magnitude that we get here is minus 300.27 Newton. Similarly, Py is equal to minus P sin theta, theta or theta P. This is equal to minus 361 sin 33.69. So again, this we'll get it as minus 200.24 Newton. So we have calculated the components of P, Px and Py with respect to xy axis parallel and perpendicular to horizontal plane. Now we'll resolve the force P with respect to xy axis drawn parallel and perpendicular to inclined plane. So already the components are shown here as we discussed. So this is the angle alpha P which we need to find. Is this angle equal to this angle? No, it's not correct. Somebody may say tan alpha p is equal to 2 by 3, but this is wrong. You observe here that px line is drawn parallel to the inclined plane. So if I take the line of action of this force P, which is intersecting these two parallel lines, then this angle will be equal to this angle, not this angle. So directly you are not going to get the angle here. For that we need to draw two lines. One line parallelly and another line vertically at this joint. Now this angle is alpha. How are you going to get this alpha p? We need to find this angle separately and this angle separately. Let us say that this is theta 1 and this is theta 2. So finding the angles theta 1 and theta 2, then alpha p will be equal to theta 1 plus theta 2. So let us find theta 1 and theta 2. So observe where are the parallel lines. You see here we have this theta 2 one line, and if I draw one line along this horizontal 3, these are the two parallel lines. Now this force is intersecting like this. Okay. So then if you observe here, this angle will be equal to this angle. So this is nothing but theta 2. So therefore theta 2 is equal to tan inverse 2 by 3. Which you will get it as 33.69 degrees. Now we will find theta 1. Again, if you observe here, this px is one line which is drawn parallel to this inclined line. And here we have drawn one line horizontal, and here this line is also horizontal. So if you observe these two here, these two are parallel lines and these two are parallel lines. So this angle is nothing but equal to this angle. Okay, so that means this angle is theta 1. So therefore, theta 1 is equal to tan inverse 3 by 4, which you will get it as 36.86 degrees. So therefore, what is the total value of alpha p here? Alpha p is equal to theta 1 plus theta 2. So 33.69 plus 36.86. So total you will get it as 70.56 degrees. So once we got this value of alpha p, now we can find px and py. Simply px is equal to minus p cos alpha p, which is nothing but minus 361 Newton cos alpha p, that is 70.56. So px will be equal to minus 120 Newton. Similarly, py is equal to minus p sin alpha p, which is nothing but minus 361 sin 70.56, which is equal to minus 339.45 Newton. So we have calculated the components of P, Px and Py with respect to an axis which are drawn parallel and perpendicular to the inclined plane. So that's all for now. Thanks for watching. See you in my next video.